So welcome to Design a Helper function. The purpose of this video is to help you integrate the knowledge that you've gained through the section and to do a slightly larger chunk of work on your own. But the actual code you're going to have to write is quite simple. We're also, in my solution, going to talk about something called implicit dependencies. And at the end of it, your code will deal properly with things that are not all lowercase. So here's that example of planet. And it's going to say, no, enter all lowercase, steering the user towards entering input that's valid for the game. So in this video, we're going to integrate your previous knowledge by getting lowercase checking working all on your own. Not doing anything new, just reapplying knowledge that we've used before. So declare and define is lowercase, a helper method. We've made helper methods before. Use a range-based for loop that we just learned about. Use the auto keyword that we also just started experimenting with. Handle strings of 0 length, \0 and spaces. \0 is the null character and it ends a string, and a user entering that may mess things up, so let's test for that. Excuse me, by the way, if I've confused \/ and /0. Anywhere else, it is \0 like that for the termination character, the null character of a string. Hint, a method called isLower, spelled like that, may help. Share your solution for discussion in the discussions would be great. And succeed or fail, now I truly believe fail stands for from adversity I learn. I want you to pat yourself on the back. So go ahead, pause the video and have a go at that now. Welcome back. So how are we going to go about this? Helper method, what does that mean? It means that if we look at the public declaration of bool cow game, it's not there, it's down in the private. It's very much like is-isogram. It's going to be a bool is lowercase f string, because we're going to take in a string and it's going to be constant because we don't want it to change anything. Cool, let's go ahead. Oh, I need a capital S on the string. Let's go ahead and implement that. Boom, here we go, there it is. So how are we going to do it? Well, let's use what we've learned. For, let's use a range-based for loop. So close the brackets, auto, letter, in, which is as a colon, word, capital word, and of course I need to give my variable a handle. Now, by the way, on whether or not you give your variables a name in the header file, it's kind of up to you. It's kind of cleaner without. It doesn't really matter what you call this thing, right? But if it's going to be descriptive to give it a name here, then go ahead and give it a name here. It's kind of style at this stage. It doesn't actually change anything because you don't need, in the prototypes here, to be giving your parameters actual names. So I tend to not give them a name in the header just to keep this as clean and simple as possible. And then when I come over here, I tend to then decide what the parameter name is going to be, which is, it is a parameter here, by the way. There is at the end of the slide deck for this section, I quite clearly show you what the difference between a parameter and an argument is, but I'll just tell you. You define a parameter, so when you're defining or declaring a function, that is the parameter there. Okay, and then you call an argument. Just remember, you call people up for an argument. So where you actually call the methods, like here, the guess here is an argument when you're calling it, and it's a parameter when you're defining or declaring the method. All right, anyway, so for auto letter in word. Now let's use the spaced out notation this time because it's a relatively short function. Okay, so for each letter in the word. By the way, where's my pseudocode? So that's not very good. We don't actually need to pseudocode, however, this bit. That's kind of obvious what it does for the letters in the word, but I'm going to pseudocode here before I write the details. If not a lowercase letter, then return false. Otherwise, return true. Change this round, right? And I can return false into an actual piece of code there now, and now I just have to write the if statement. If not a lowercase letter. How do we say that? Well, if. Now we've got a not, and then we've got is lower. We have a method there, and it takes in the letter. So if it's not a lowercase letter, then what do we want to do? We want to return false. And I would say I'm going to use the spaced out bracket syntax there. Otherwise, we return true. So that is a pretty simple method. Let's go ahead and test to see if it works properly. So if I go planet now with a capital P, what happens? Nothing, it's not working. What have I done wrong? Well, what I've possibly done wrong is never called is lowercase. Let's go and have a look. This would be a common mistake. We just say if false. What we actually want to be doing, if not is lowercase, guess. Okay? Now let's try it, and then I'm going to talk about something called implicit dependencies before we leave this video. Planet, please enter all lowercase. A, please enter all lowercase. AA, please enter a word without repeating letters. Okay, now I think this is actually guiding me quite nicely. If I enter nothing, it says a 6-letter word. If I enter A, it says a 6-letter word. If I enter AA, it says don't enter repeating letters. But the order in which it gives me these errors is determined by the order of the if statements in the check guess validity. Okay? So we actually want to be able to change this order round. There's absolutely no reason that we have to stick to this order. If this order is vital, for example, we can only pass isograms into is lower or something like that. So if these have to be done in order, then we have something called an implicit dependency. What's an implicit dependency? Implicit means suggested, though not directly expressed. A dependency means reliant on something else. So an implicit dependency is when it's not completely clear that one thing depends on another. For example, the orders of the checks in this check guess validity. And we don't want that. We've just arbitrarily pretty much come up with this order, and it has it should only have one side effect. It could have the side effect that your code works, and that would be a really bad side effect. If your code doesn't work with these things in any order, then these methods are not sufficiently self-contained. You know how we went to an effort to make sure that is_isogram works for all types of strings? Well, it's the same thing for is lowercase. One way of testing is lowercase would actually be to do a block exclude here with a /*, and then here we could go a */, and that would comment all this stuff above.
Now, at the time of recording, something must have happened to Ben's machine, because what we see when he is testing it is not actually the result of him having made this change. So ignore that and do test it out for yourself.
Does it work with a blank string? Yes. Does it work with a \0, the null character? Yes. Does it work with a mix of characters? Yes. Please enter a word without repeating letters. Does it work with just 6 random letters? Yes. Good.
So feel free to go ahead for yourself and try this with the code commented out. Now, Ben's going to be actually putting it back to how it was before, and you can obviously go ahead and try this out for each individual method yourself. It should work independently of the order here.
And it's important that all of these methods actually work on their own. I'm not going to go through in detail, but I want to get the point across that none of these should depend on the other one having been executed above, and we should always be able to change the order of if checks like this. For example, when doing performance profiling, we might find the thing that happens most often should be put at the top to save the rest of the checks being done. Okay, so that's implicit dependencies. We want to avoid them. The second thing about this, which is implicitly happening, which is not totally clear unless you think about it, but I'm comfortable with it, is that it is changing the feedback you give to the user. It's changing the way in which we guide the user towards putting the right thing in. What's wrong with that? Well, it has repeating letters, but it's also too short. If I wrote AAD, then it's also repeating letters, but how about AND? Too short. Yeah, AND, or lowercase. It's kind of a design decision, but I only want to give them one piece of guiding information at a time. In this case, this is absolutely fine. It very quickly guides them towards entering something that we want. So we're pretty much there with this game. So congratulations if you got this one done, and I'll see you soon.